First of all, nice to meet everyone, and thanks for inviting me here today. I love the opportunity to speak and talk about our center anytime I can. So I am part of a relatively new research center of excellence at the University of New Brunswick called the Marine Additive Manufacturing Center of Excellence. And we started in 2017, and we've been going strong for a bit before then, but working in metal additive manufacturing or 3D printing of metals. So we're part of sort of a center of excellence or research center ecosystem in advanced manufacturing at UNB. We focus specifically on metal 3D printing, but we fit nicely into a few other research centers at UNB, such as offsite construction, the Center for Nuclear Energy and Wood Science Technology, where we're developing new manufacturing techniques and technologies to try and lead us into the future of manufacturing. So for those who might not have heard of additive manufacturing, another term for this is industrial 3D printing, and that is where essentially you're now manufacturing functional parts using metal 3D printers. I think historically 3D printing has been thought of as plastic 3D printing and for prototyping. We're actually in beginning to, and a lot of companies are adopting actually using 3D printing for actual production components. And the machine that we have at our print center, which is located in St. John, is a GE Concept laser machine, which is a GE's sort of workhorse industrial 3D printer. The bulk of the research and the real strength of MANFC, our research center, is materials development. In additive manufacturing, I think a lot of the hindrances to innovation are just the limited number of materials you have to work with. When you're thinking of 3D printing, there are really a handful of metals that exist for 3D printing that are used industrially, and there are thousands of metals that are used around the world for various applications. So our research is trying to use advanced characterization. We have some of the best equipment in the world to figure out how exactly we need to print different kinds of materials so that we can sort of increase that repertoire of materials that we can actually use in 3D printing. And on top of this, we want to make sure after we've printed our materials, they have good properties and they can meet the needs of whatever application that they're going to be used for. So we have various testing equipment for mechanical testing, we have corrosion testing, fatigue testing, and then we also have access to UNB's BAM lab, or Ballistic and Materials Lab, where we can actually do hypersonic and high velocity impact testing for example, like aerospace application. And then bringing this into the digital age, we do a lot of modeling and simulation as well. So not only do we want to be able to print materials and then test them, we want to develop software that can actually simulate material behavior based on the actual physics that we find within the material. And then once we do that, what we can do is reverse engineer the material. And with additive manufacturing, you can actually control within the material itself the behavior that would affect the bulk response of the material. So we're using machine learning and advanced computation to be able to understand the materials even deeper than just doing characterization. So we started in 2017, and one of our major partners was Irving Shipbuilding. They understood the need for advanced manufacturing as they are part of the National Shipbuilding Procurement Strategy, and they're building Canada's next generation of Arctic offshore patrol ships, as well as the Canadian surface combatant ships. So 3D printing kind of is a obvious potential benefit for this industry, as when a ship needs repair, oftentimes you have lead times for spare parts that could be months and months of having a ship, a critical piece of equipment that is out of commission because it's waiting on spare parts is sort of very, very costly and unacceptable. So having 3D printing as a means to sort of fill that gap for lead time and production time provides huge potential benefit to industries like the marine industry. We also do research in other industries. So here are just some examples. We have projects in aerospace, oil and gas, nuclear energy, and tool and die, where the tool and die one is fairly interesting, where we're actually developing technology where we actually 3D print and repair die equipment. So instead of purchasing a whole new die, you can actually create a new die from a base or repair an old die that maybe has been damaged, which can significantly reduce the cost of tool making. We're always looking to engage, and one of our missions is to sort of educate as many people as we can and as many companies as we can about additive manufacturing and how it can help. We work very closely with GE and their AdWorks team to sort of teach about commercialization, teach about the business of additive, what is the full cost of additive in terms of not just 3D printing, but how could it change a production ecosystem, and what are all the cost benefits that you could see by thinking of having an additive solution be part of your production. And then lastly, this is just a final slide where I have a picture of some keychains that we 3D printed. Last fall, we had our technology launch where we unveiled our 3D print center. And so these are just some keychains that we 3D printed out of a tool steel. And if you ever are interested in anything, please feel free to reach out to either myself or Dr. Mohammadi, who is our research director at the center. Our contact information is at the bottom here, and I'll make sure that that's available through the webinar as well.